Hi guys, we're doing lesson 17 out of your daily math activity workbook. Let's go ahead and get started with number 1. So number 1 says 55 times 44. The first thing I notice is that this is a 2-digit by 2-digit multiplication. So we can do the standard algorithm, but for our practicing purposes, let's go ahead and do area model. So I'm going to split my 2-digit numbers up by their value. So inside of this 55, I know that there are 5 tens, which would equal 50, and 5 ones. And together, 50 and 5 equal 55. Same with 44. There are 4 tens, which would be 40, and 4 ones. Okay, now I'm going to just multiply 40 times 50. That's pretty hard for me to do, but I can think of it simpler terms. 4 times 5 is 20. And now I can add 2 zeros, a 0 from the 40 and a 0 from the 50. Okay, now I can do 40 times 5. Again, I'm going to do 4 times 5 is 20. And there are no zeros in 5, so I don't need to add a 0 from that. But there is a 0 in 40, so I'm going to go ahead and add that there. So 40 times 5 is 200. Now let's do 4 times 50. So 4 times 5, again, is 20. And add 1 0 from the 50. And now what's left in my last box is 4 times 5, and I know that is 20. So kind of cool, we have a pattern here. It goes from 20, 200, and 2,000. So now what do? I add up all of the products of each box, also known as partial products, all together to get the final product of what 55 times 44 is. So my final answer to 55 times 44 is 2,420. All right, let's move on to number 2. We're also going to skip this number line because the problem got cut off for us. All right, number 2. Cole bought 22 apples at the store. 22 apples. He cut each one into 8 pieces. So cut, that's kind of to me like dividing it up into 8 pieces. That's what my mind is thinking. So each one he's cutting into 8 pieces. So we can also think about that as multiplying. Each one is now going to be multiplied by 8. So now he's going to have 8 for each one. Okay? So how many total apple pieces does Cole have now? So he started with 22 apples. He's cutting each apple into 8 pieces so that he gets 8 pieces for each apple. So I'm in essence multiplying 22 times 8 here to get a total number of pieces. So 22 times 8, I'm going to do standard algorithm for this one, because it's only 2 by 1. So 8 times 2 is 16. Write the ones, carry the group of 10. 8 times 2 is 16 again, but this time I'm going to add what's on top. So 16 plus 1 is 17. And that's the product. That's the answer. Cole now has 176 apple pieces. All right, let's do number 3, subtract. So they already tell us what to do. 7/8 minus or subtract 4/8. So what we started learning about fractions is that when we add and subtract fractions, our denominators, which are the number on bottom, which represents our total number of pieces that our whole is divided up into. So this is 8. So if we had a shape here, I could divide this into 8 pieces total. Okay, so this one would be 7/8. 1, 2, 3, 4, 5, 6, 7/8. Okay, That would represent 7/8. And I want to subtract 4/8. So I want to take away 4/8. So 1, 2, 3, 4. And what do I have left? I still have 1, 2, 3/8. And as you can see, when our denominators are the same, we can just subtract or add straight across. So 7 minus 4 is going to be 3. So our answer is 3/8. All right, number 4. Draw a line of symmetry for the isosceles triangle. So here's an isosceles triangle. I'm going to draw one here as best I can, although mine kind of looks like a witch's hat. I'm going to erase that part. So here's my isosceles triangle. I just turned it on the side. So symmetry is talking about equal or identical pieces. So imagine that there's a line that could divide this shape here, this isosceles triangle, into equal pieces, so that if it were put in front of a mirror, both sides would be the same. So I'm going to think about, if this were my line here, would this side be the same as this side? No, we can already see that this shape here is different than this shape down here. Okay, so that would not be correct. All right, so thinking about, where could I draw this imaginary line where both sides would be identical? And that's usually going to be in the center. Okay, so here's my imaginary line. Okay, and if I drew this perfectly and accurately, both sides, my left side and my right side, are the same. They're identical. So the line of symmetry is going to be right here in the middle. So all you would need to do is just draw a line, kind of straight right there to divide it in half. And now you're done. Okay, last one, number 5. 9,140 divided by 4. Okay, 9,140 divided by 4. Okay, so I'm going to use the standard algorithm for this, so long division. We're going to remember our steps. Does McDonald's sell cheeseburgers here? So first step is to divide 4 into 9. How many times can 4 go into 9 without going over? Twice. Now I'm going to multiply. 2 times 4 is 8. Now I'm going to subtract. 9 minus 8 is 1. Now I'm going to check my work. Can 4 go into 1? No. Do I have something that I can bring down? Yes, it's a 1. So I'm going to bring down the 1. And now I go back to the beginning to repeat those steps. So divide. Now can 4 go into 11? Yes, it can. It can go into it twice without going over. Now I'm going to multiply. 2 times 4 is 8. I'm going to go ahead and erase my steps here because it's going into my work. I'll write them over here. Alright, so we had divided and then we multiplied, so now we're at subtract. 11 minus 8 is going to be 3. Now I'm checking my work. Can 4 go into 3? No. But do I have something I can bring down? Yes, I can bring down this 4. Now I'm going to go all the way back and start over again. So now I'm thinking about, can 4 go into 34? Okay, and I know that it can, so I'm going to skip count in my head or out loud to see how far. So 4, 8, 12, 16, 20, 24, 28, 32, then the next one would be 36, so that'd be too high. So 4 can go into 34 8 times. Now I'm going to multiply. 8 times 4 is 32. Now I'm going to subtract. 34 minus 32 is 2. Now I'm going to check my work. Can 4 go into 2? Nope. Do I have something to bring down? Yes, it's the 0. And this is my last one, so I'm going to go back again to start over to divide. Now I'm thinking about, can 4 go into 20? Yes, it can. You can go into it 5 times. I'm going to put 5 on top. Now I'm going to multiply 5 times 4 is 20. Now I'm going to subtract. 20 minus 20 is 0. Now I'm going to check. 4 can't go into 0. And I don't have anything to bring down, so I'm going to stop there. This would be my remainder if I had anything left, but there's nothing left. So the answer to this division problem is 2,285. And we're all done for today. Great job.